Okay, the Texas Panhandle is finally getting some rain. It's May 23rd, 2014, and this storm complex has brought about an inch of rain to the Panhandle, and up to yesterday, areas like Lubbock have gotten less than an inch of rain in 5.5 months. So for the calendar year of 2014, up to yesterday, this area had gotten less than 1 inch in 5.5 months. So this is welcome relief, except now we see a Harp Downburst here. There is a Harp Downburst happening right here, and there's a Harp Downburst happening down here also. And let me show you the evidence for that. Here's the goes east, and this is right at daybreak. And okay, there's a dry line right here, and the humid surface wind is going straight west, and the jet stream is going northeast at an angle like this. So the mixing area here is where we should see thunderstorms reforming, because humid air is buoyant. It's like helium. It wants to rise up because water molecule is much lighter than the nitrogen molecule, N2. So right here, these storms here should be building, and instead we see them being crushed. And right here we also see two Harp outflow boundary rings. Let me zoom on that. Whoops. Right here, these two rings. There's two rings that form here. I need to stop it, I guess. Okay, right here. We've got these two rings that form. These two rings, and they kind of extend up here. But this area here is where these storms are being crushed. Here's the dry line. West of this is dry air. East of this is extremely humid air that's also traveling to the west. So let me just step through. We see this outflow boundary moving, and it's moved more, and now it's starting to dissipate. Okay, here's daybreak. Look at this. Here's a thunderstorm that's bubbled up. Thunderstorm right along the dry line. And now they're getting crushed down, and now we start to see the Harp outflow boundary. And here's the two rings. And you know, if I go to here's a surface pressure map, and basically there's a light westerly wind, but there's just nothing here that's going to cause those rings at the surface. And the jet stream is going to the northeast. Nothing here that's going to form those rings at the surface. And if we look back at the next rad, you can see the storms on this edge here getting eaten away. And little guys like this is the clouds, this is the storm we were looking at earlier. You know, this little guy right here, instead of building up, he disappears. That's the Harp downflow, the Harp downburst of dry air. And so the Harp operators know they don't have enough energy, plus it's too early in the morning to reach all the way to this one. They have limited range at daybreak. So they're just going to attack this dry line here to cut this edge off here. So instead of getting a couple 3 inches, which would be so great for the cotton crop, remember, 1/3 of the world's cotton is grown right here. 1/3. So a rain like this makes or breaks the entire year for the majority of the farmers, because most of this cotton in that area is dry land, non-irrigated. So, and we can look from the east, from the Pacific goes, and computer's really slow. Let's see. And we can see a nice view here with the three-dimensional relief. So here's the thunderstorm that was building up, building up, building up, and all of a sudden it goes down to nothing. That's not normal. Next to a dry line, that should be building up. At least in most cases. And hopefully we can see this. There's the harp ring there. Okay, so there's a little thunderstorm building up, getting squashed. And here's our harp outflow boundary, which then expands. And keep in mind, to hide this activity, they are now photoshopping these satellite maps just horrible. I mean, there's just no detail on these maps anymore. I mean, look at this. It's all fuzzy. It's all just hazed over. I think the meteorologists are going to complain because there's no detail. I mean, here's the water vapor map, and that shows you where the dry line is. Also shows you these clouds trying to pop up, and then they immediately get smeared away. Well, part of that is the jet stream. The jet stream's very fast, but to my mind, this is still a harp attack. So I just wanted to make a clear case for this before updating the maps and then losing this data. Another thing they've started doing on these maps is, since I've taught them that the water vapor map is the one that shows the chemtrails, they have now edited these maps to remove all the chemtrails. Virtually all of the chemtrails are removed. So this is unfortunate because it limits the public's ability to study this and what's being done to them. So, in other words, we've got to take a more ground-based approach, and that means to build the HARP antenna, which I have described in the HARP signal on oscilloscope video, and also to use your best digital video camcorder, digital video recorder with at least 60 zoom and digital stabilization to take pictures of the chemtrails the chemtrail planes when they are flying overhead. And there should be a way to get really good long telephoto lenses and stabilize them to get really close-up pictures of these planes. And every day they have been doing a Harp Downburst in south central Texas, and today is no exception, because if we look at the next rad, we can see this rain just getting eaten up down here, right here over Austin. So the horrific drought for the cotton farmers seems to be letting up a little bit. But, you know, 1 inch, 1.5 inches doesn't really matter, since the subsoil is completely dry, completely void of moisture, going down a couple of feet at least. I mean, it's astonishing. So, I say great for you cotton farmers who got the seeds in the ground in time. At least you're going to have some sprouted seeds, and then in a couple of weeks we'll have to worry about some more rain. But the HARP attacks continue, even though Mother Nature is trying to bring us the rain that we need. Okay, thanks for watching.